Assalamualaikum warahmatullahi wabarakatuh. Good afternoon everyone. I'm Puji Harsanto from Universitas Muhammadiyah Yogyakarta. Today I would like to present our research in this seminar, International Conference on Science and Technology 2022. The title of our research is Using Frequency and Time Domain on Identification of Bad Load Transport. And our research member is Dr. Berli Paripurna Kamil and Dr. Nur Setiawan, and also some of our students. Today outline is introduction, experiment setup, method, result and discussion, and the last is conclusion. For the introduction, Mount Merapi is one of the active volcano in the world, and the last big eruption was on 2010. And usually during eruption, Mount Merapi produces a large volume of sediment, such as stone, sand, and ash. This sediment will deposited on the mountain hill and will flow down to the closest river during rainy season and become a sediment transport as a bed load and suspended load, and will flowing down to the downstream. This photo shows that the bridge was collapsed due to the debris flow in the river, or in bahasa we call banjir lahar dingin. This is one of the issue, the impact of the bed load movement. So the volume of the bed load transport is an important thing in river morphology. So it is very important to predict or to measure the bed load transport. So the way of thinking about this research is the first is the problem is the river morphology due to the bed load transport, and how to measure the bed load transport, because until now this is still challenges for the scientists. And this idea is to measure the bed load transport using accelerometer. This accelerometer, we hope we can catch the vibration due to the impact of bed load transport during movement on the bed. So the purpose of this research is to identify the bed load characteristic due to the size and discharge of sediment transport. So in the future, if we success in this research, we hope we can do monitoring the bed load transport in the river continuously. The experiment was carried out in our laboratory in Civil Engineering Universitas Muhammadiyah Yogyakarta. We using a flame test with a 5 meter long and 10 centimeter wide. We use a constant flow condition for all experiment and bed load transport with a different diameter. This experimental scheme is this flame test have circulating water, and we feeding the sediment or material sediment in this part. So sediment will transfer to the downstream, and according to the energy of the flow, the movement of the sediment will cause vibration on the bed, and the vibration are captured by this accelerometer, and we insert this accelerometer at the bottom, and the vibration will store to the PC, and the duration for each experiment is around 10 seconds. This is some test photo, and we install the accelerometer in this part and connected to the computer to store the data. We also measure the sediment transport volume. And this is an example of a graph showing the relation between vibration amplitude and time and frequency domain. So we do 8 experiment, 8 types experiment, and each experiment we do 5 sample. And so the vibration amplitude represents the energy level which can be calculated using a root mean square. And the higher the root mean square value, the higher energy due to the impact between the grain size and also the bed. So the kurtosis is useful for the trend of a peak level of the signal in the time domain. This parameter relates to the intensity, the object causing the impact on the bed. So we analyze, use a frequency domain and also time domain. So result and discussion. This amplitude for each frequency tend to decrease as the grain size increase. It means that when the diameter is small, the moving of a grain size more frequently touch the beds comparing to the bigger diameter. So this graph is relation between amplitude and the volume of the sediment transport for each frequency. So this is in frequency domain. So the amplitude for each frequency tend to increase as the bed load transport volume increase. It's indicated that the volume of bed load transport causes the energy more higher during the movement on the bed, and the energy will increase when the volume of bed load transport also increase. And these are the graph relation between statistic parameter, root mean square, and also kurtosis, and the last is for standard deviation. The graph show that the data group for root mean square and also standard deviation more better than kurtosis. It means that root mean square and also standard deviation have good relation comparing to the kurtosis parameter. So for the root mean square and also standard deviation, the graph shows that the magnitude will increase due to the increasing of the diameter of the bed load transport. So, and also when we comparing for the root mean square and the volume of bed load transport, the graph shows that the magnitude of the root mean square and also standard deviation will increase due to the increasing of the volume of the bed load transport. But for the kurtosis, the magnitude of the kurtosis will decrease during the increasing of the volume of the bed load transport. And the last is a conclusion. Grain size, diameter, and discharge of the bed load affect on the vibration. And For the statistical parameter, the most sensitive for the parameter is on the time and frequency domain is root mean square, standard deviation, and the last is kurtosis. And for this experiment or in the research, that the accelerometer has a potential method or tool for the sediment transport measurement. So this is all of my presentation. Thank you very much.